Hello everyone. Welcome to our session in Azure Back to School. We're doing a session on engineer with Azure OpenAI building Unbreakable. My name is Nicholas, and I'm doing it with Peter Detender. So who am I? So I'm Nicholas Chang. I'm a senior platform engineer working for Kainos in Belfast in UK, and I'm a recently awarded Azure MVP. I'm a blogger, speaker, and I'm quite active in the community, and I love to contribute back to the community, to tech community. And I'm also on my user group, and I got a podcast as well. So you follow me on social media. I'm a Linktree account there.
Hey everyone, I'm Peter Detender, originally from Belgium, but moved to the Redmond area about 3 years ago. I'm Microsoft technical trainer, and out of helping customers every single week or even every day now, I mainly train on Azure architecting, DevOps, and eventually moved to application migration and developing, and more recently AI and Copilot. If you got any questions after watching the session or even during, don't hesitate reaching out on Twitter, LinkedIn, or send me an email.
Yep, so we just want to say a huge, big thank you to the organizer for this amazing event. I just back to the big thank you to Derek Smith and Don Hazer. So we love to see it grow as well in the global Azure community. So about what is chaos engineering to people that is not unsure about what it is, how you can integrate chaos engineering with Azure. You can implement chaos as well with some monitoring tips and tricks, as well. Just give you some conclusion what we find, what the best things you can do forward. What is chaos? And so the DevOps method is to more be fair reducing time, just any other. So while DevOps and SRE for software development lifecycle equal more in terms of failure. So experiment could be like typical running against production, running system to identify any loopholes and pitfall you want to run it, which make the system less reliable.
Cool. So the idea with chaos engineering and bringing OpenAI in it together, or just AI if you want, we would recommend 3 different stages or phases to go through. So the first one we would describe as the design phase, where it really means that AI can help you in generating scenarios. And we'll walk you through a few demos later on. And the scenarios we're obviously talking about chaos engineering scenarios. That means injecting faults. Next to that, you can actually use that information like executing. How do you get started? What kind of faults do I need to inject? And once you know the faults, how do I actually move them into my chaos management application? Where, since we're mainly focusing on Azure, remember it is Chaos Studio, and we'll show you an example how you can rely on AI to help you composing those fault injections. And then obviously after you've been running your faults, you've been, chaos engineering for a couple of times, it also means that you need to learn from the outcome. So that's where the analysis phase comes in, where Nicholas will show you later on how to use Azure ML Studio, learn from log files, and actually coming up with some cool results from there. Now I'm going to switch to my screen here, and that allows me to walk you through some demos as well. There we go. That should be it. Now, we talked about high-level chaos engineering. We talked a little bit how your Azure AI can help you with that, but a little bit more specific, and this is a teaser to the few demos that I want to integrate. So when we talk about AI in the Azure world, in the Microsoft world, it's mainly using Copilot. So a few examples where I would say it really shows the starting point of chaos engineering. To me, it starts with what are we running? Like learning from your environment. Maybe even in the true designing phase, where you come up with a diagram. Everything always works on a diagram. And then from there, actually using the diagram to learn from it. Or just presenting a prompt or a diagram to Copilot and asking, how can we optimize this environment? Or why not just explaining the building blocks? So I'm going to switch to Copilot. And let me bring this down. Here we go. So I'm connecting to copilot.microsoft.com, and you need to authenticate. Now from here, you can choose between your personal account, your corporate account, if you do have the Copilot license. I'm using a personal account. So I'm not really doing anything specific. It's not because I'm a Microsoft employee, I can show you more stuff because it's just using my Peter at Outlook. So one of the first examples here is uploading an image where I do have a diagram, and this is just a description of the file.
Sorry, Peter, can you share your screen again? It's gone.
Oh, no. Present, share
I need
screen.
to edit that part.
Entire screen.
Okay.
Should be on. Cool. I'll start again from this Copilot piece, right? Then it's easy for you to edit and just move it out. So I'm in copilot.microsoft.com over here, and I'm authenticated as Peter. Now, important, this is just a personal account. So I'm using Peter at outlook.com. And from here, we can start doing some Copilot integrated chaos engineering using my Peter at Outlook personal account. And one of the first things I could show you here is explain a diagram. So I got a super basic example where I'm going to upload and I'm going to ask Copilot, can you explain this diagram for me? Now this diagram, I'll zoom in a little bit, is showing like a collection of Azure functions. There's an event grid, there's Office 365, there's AI computer vision, and a few services on the side. So without knowing anything about this workload, the Copilot integration is now providing a pretty okay description. But it's not super detailed. It's just recognizing, I would say, primarily based on the keywords I have in my diagram. So I'm going to make this a little bit more exciting. Uploading another diagram, and I'm going to do the same. Can you provide a detailed description of this diagram? Highlight the Azure services and provide me a table, because that's easy to copy and paste. Provide me a table with a short description of each service. So it's a little bit more polished. It has nice Azure official diagrams in there. And again, still showing, let me make it a bit bigger, 3 different functions doing something. There's an Azure web app, we got blob storage, we got AI document intelligence, and some databases. Well, now it's doing the same thing, still providing a pretty okay description, but nicely presenting it in a table. I'm going to stop this one. We're going to move it into a little bit more advanced chaos engineering. And I'm going to reuse my example from before, where now it's showing a single web app. Now imagine that my business asks for reliability. It's the SRE part in the chaos engineering definition, right? So now we could go like, for the previously used diagram, can you provide suggestions on how to make the web app more reliable? You can provide multiple solutions. For each, use descriptions from learn.microsoft.com. Now you can see that every now and then there's typos, and our large language model doesn't even care about it. So the mindset here is that we do have a web app. It's just coming from the diagram, so it learned a bit of that. And what I'm asking now is, just provide me information on how to make this more resilient. So it's providing a lot of descriptions. You need to integrate scaling, geo-redundancy, caching, logging, and so on and so on. Now from here, we can make it even more exciting, because now we know, like, okay, we have our topology, we have the architecture, we learned from the diagrams. We're leaning a little bit more into actually using our Chaos Studio. That's, again, the tool we use in Azure. But let's say you heard about it, but you don't really know how to use it. Now we could go like, can you build me an Azure ARM template allowing me to deploy the above architecture? And what I want to do here is showing you how super high level you can actually start, where obviously in a real life environment, you would start high level and then gradually moving down. But as you can see here, it's nicely building up an ARM template. It's adding some naming conventions, and not just for the web app, but actually for the full diagram. While this is running, so in short, these are the few demos that I walked you through: analyzing diagrams, highlighting shortcomings, like help me identifying how to make my web app more reliable. But that's not the only capability we have, because now you might be in a mindset where you want to move from that designing phase, discovery phase, into executing. What we're meaning here is building your own Copilot, and actually not just relying on public web information, but grounding it, like setting the scope, defining the boundaries of what your custom Copilot can do. And again, a lot of cool examples here. You can actually turn Copilot into a certified Microsoft technical trainer, for example, to limit the scope of what it can answer. You can use grounding in prompts. You can use grounding in system messages, and I'll show you what it means, or just reusing a lot of the examples I share and really building out your own custom Copilot scenarios. I already showed you the bicep arm generation, so that's an easy one. So I'm going to switch back to my portal, but let me quickly check what it did. So it produced a pretty cool ARM template. And on top of that, although I didn't ask for it, it actually provides an explanation, and it also shows me how to deploy this. Pretty cool. Now, the other option in custom Copilots, I'm juggling across my browsers. Where is my Copilot? Over here. Cool. So in the backend, I deployed Azure AI Studio and Azure AI Service to actually help me building up my playground. And then one of the first things is deploying a model. I'm using the GPT from OpenAI, but there's a lot of other models supported. Now, I talked about grounding, and instead of me typing and making a huge amount of mistakes, I'm going to grab a prompt here from the site, because now what I'm going to do is defining instructions. So by design, what I showed you in web is that pretty generic AI assistant, where now I can inject a more specific prompt explaining you're an Azure technical trainer. Yes, I'm automating my own job, right? Proficient in Azure architecture, most Azure services, AI, and Copilot. You can answer any questions about Azure with technical accuracy. Be nice, be polite. That's what trainers are doing. And then if you receive questions outside of the Azure technical domain, apologize, be nice. And then being a bit loyal to my roots, I want to obviously spread the message to the world to learn something about Belgian beers. And then when you have provided that answer, close with a conversation follow-up question to really get you in that mindset. So I could do the same demos as before, but now it's just my own playground. I'm going to apply my changes first of all. Well, now I could ask a question, how, or let's say, what are the different Azure load balancing services for web apps? Well, now it's hopefully, there we go, providing a nice, good description. I could go, what Chaos Studio faults would you recommend for a web app scenario? Where again, it's telling me as a chaos engineer or a site reliability engineer or a platform engineer, like Nick, what we have to do here. So it's coming up with a few nice examples. And then last, can you help me writing an ARM template for the Chaos Studio experiments listed above? Well, now it's producing once more a sample of an ARM template, but the scoping is a lot more specific. What I find out in the playground is that there's no way to stop it, but it doesn't really need to run for a long time. And then last demo here, and then I'm going to hand it over to Nicholas again, is it actually loyal to my system message, where I define the grounding, like you can only answer Azure technical questions. So can you explain load balancing in AWS? Obviously, as a Azure technical trainer, you might be up to speed on AWS. And now it's obviously not listening to my system prompt. I've been testing this out so many times already, and it actually did a good job. You can only answer Azure questions. So let's try. This is not an Azure question. Why did you answer? So now it's apologizing. Well, too late. Can you describe AWS Beanstalk? And it's still not listening. Well, okay, fine. I mean, not too important. The mindset is that you can define your own grounding rules. You can define your system assistant messages. And then normally, I would say it would be pretty bound to that one. But in this case, I guess it's because it's Azure back to school and it doesn't really listen to the teachers yet. But that's totally fine. You hopefully get the idea out of it. So Nick, over to you.
So thanks for that, Peter. So I'm going to talk about AI doing chaos engineering phrase. So there's different ways that we can use AI. So there's different ways that we can do. Hello. So I'm going to talk to you about AI doing case engineer in the analysis phase. So you can use Microsoft Copilot to do a range of features and actions. For example, analyze results from chaos experiments when integrate with a Chaos Studio as well. So you can also use it to integrate ML, Azure ML, which stands for Azure Machine Learning, to read data from Log Analytics Workspace to analyze predictions and fault rates, like an app resource like App Service, and identify opportunities for improvement actual data. So that means to be able to predict any improvement they can make on your resources. In this demo, I'm going to show you what Azure ML analysis of log analytics workspace will look like and help you. So let me just share my screen. You should see my screen. So the first is that when you're on your resource group, go to Azure Machine Learning Workspace. So it's already created one already. So once you create a machine, like I've already created one. Sorry, it's taking a while, so I've already created. So this is what it looks like. So the workspace home. When you start a workspace, this is what it look like. But you have different panelists here. The first thing you're going to do is I would advise you to create your data. So data is where it's bunch of like files or source where the machine learning job will be able to read and analyze from. So to create data, you just normally click create, and then there's different types of data you can create. So I've already created one before, and I'll show you. So data assets. So I created a data of 13, and my data 13 hook up into my data query data.csv. This could be any sources, could be storage account. Click store the log, you can see Postgres, MySQL. So these are various data you create. So if you enter your details for blob storage, enter subscription ID in storage account name, it will find you. So mine will be AI Storage Chaos Studio Demo, and give it to a blog name. So by instance, I will connect to a blog like HTML, logs or so. Then hook it onto an account key, your storage account key. So once this, I've already created one already. So you should get, once you created it, it should populate here. So I created one before called data store. Once you create a data store, you can see it's been created by clicking on the connection tab here, and all the data store is here as well. So if you have any, if you want make any connection to any resources like ACR, okay, you can just create a new connection here. And there are different various of external resources in Azure that you can create it. For example, Azure Azure Container Registry, which I've created a connection here as well. So in this demo, I'm going to show you how I took the logs from an app service, put it in a storage account that on the Log Analytics workspace, and be able to use Azure Machine Learning in order to analyze the logs data. So I'm going to show you how you can use the ClickOps ways, showing you the automated ML jobs. When you create an automated ML jobs, it will automatically create a jobs here as well. So here you can see all the jobs. It's just taking a while to here. So you can see some jobs being created as well. So I'll go guide you through how you create one. To create one is straightforward. Just give it a job name. So Azure back to school. So I think these need to be lowercase as well. Yeah, so I left it as default job. You can do previous experiment. So I've already done one already. And you can do different type. So you can use classification into predict or regression type areas in order to predict the values and stuff. But in my instance, I use classification type. This needs to be 2 or more rows. And then find your data, connect to your data source, click next, and have certain columns to predict on. So I have already done it already. So I'm going to show you what it looks like here. You can do a test data to validate the column as well, the test, and give you an option to create compute as well. So compute is where the jobs are running on. It could be like a VM, like a virtual machine scale set, a cluster. So to create a compute here, is under here compute. So I would probably advise you to create it beforehand in compute. And this is just the number of instances to create compute. So I've already created one before, so I will let you have a look at what it looks like. So I've already created a job here called an experiment is AutoML log issue prediction. You see some completed. So previously I was on the automated ML, it was some failing I was looking at. So once the experiment was being failed, it's been successful, you get green tick here. And for my instance, I see some values here. So you can use these values as the prediction of your data. So this needs to be converted as well. So you can also add data guardrail as well. So I've not looked into the data guardrail yet. And you can also have some modules, different kind of modules they use as well. This is the output folder. You can see it's all kind using auto driver Python scripts as well. Yeah, so you can also use this for different ways. You can see you can use this in VS Code in Python if you want to create different modules and stuff. So let's jump on a slide. Let me quickly share my screen again. Okay, so I've shown you how a demo. I show you a demo on how you can use Azure ML to analyze logs data and for values and things. So the demo used by collecting logs for my instance would be Azure App Service, but you can use it to collect any logs as well. So and then I process those logs into Azure Log Analytics Workspace and Azure Storage, and then you can use it. The feature extraction and module training, you can use it by using queries in the Log Analytics Workspace in order to pinpoint what specific logs you need as well. And the module training is like it will train from once module has been added on the machine learning workspace. You're able to train data, and maybe in the future you can predict future issues and present your findings. So I didn't manage to get time to present the findings in the dashboard, but you could potentially do that as well. Present the finding in the dashboard. So some of the key takeaways is that in this session we talk about give you a brief introduction what's chaos engineering, show you how you can integrate chaos engineering with Azure OpenAI easily, and how you can implement some chaos experiments. We briefly touch bit on some demos as well, and give you how you can monitor your chaos engineering as well as your Azure OpenAI resources, and use it to further mitigate any issues in your Azure resource. So I hope you enjoyed. And with that in mind, we would like to take our time to thank you for watching this session and how you can integrate AI solution with such as Microsoft Copilot into Chaos Engineer. Thanks, Derek and Dwayne, for your invite. Hopefully see you next year again. Thank you. Bye.